like we're rolling here.
All right.
Good afternoon, everybody.
Yeah, good afternoon. Let's get started then. So first of all, I'd like to thank Prepare.ai for putting on this presentation and for all of you for attending today's session. My name's Nick Magnuson. I'm the CEO of Big Squid, a machine learning software company. I'll be joined shortly, as you've already heard, from Mark Hopkins of Skullcandy. And we're both thrilled to talk to you today about AI in the workplace. This is I think, a great and timely topic. And what I'm going to do in the next 5 to 10 minutes is set the foundation for the talk by covering some of the origins of AI, the evolution of machine learning specifically, and how we see our customers using it today before enlisting Mark to talk more specifically about just that at Skullcandy. So let's jump in, and I'm going to start sharing out my screen here, and we'll get going. This guy play from current slide. Give me a thumbs up, Mark, if you can see my screen.
Yep.
All right. Well, good deal. So let's start by talking about what AI in the workplace really means. So I'll give you guys a second to read through this graphic here. And normally I would present this and get a few chuckles, but in a virtual environment, I'm just going to assume that at least you got a smirk. You know, one of the things that this does highlight for me anyway is there is not a clear consensus across organizations on how AI does apply to the workplace. So let me start by just giving a little bit of a background in terms of how we got to where we are with AI today. AI has actually been around for a very long time. It's actually part of our mythology. It's part of science fiction. But more specifically, AI was born largely due to the work of Alan Turing in sort of the 1950s era. He officially sort of identified the ability to create artificial intelligence largely through the use of computers. Followed very shortly thereafter by Arthur Samuel, who actually coined the term machine learning, which is a fairly common application of AI today. Most of you are probably familiar with AI through some of the feats that AI has achieved over the years. Most notably in the 90s was Deep Blue finally beating Kasparov in chess. I remember watching virtually unbeaten Ken Jennings until Watson ended up beating him at Jeopardy. And then more recently, Google DeepMind beat Lee Sedol in Go, in AlphaGo. So, you know, we've seen these things evolve. In today's world, we see AI all over the place. AI is in search algorithms. It's used in spam filters. Obviously, stuff like Siri and Alexa are all voice-driven and use AI as their backbone. And more specifically, let's talk about what AI means and how it relates to machine learning, because these terms are often, you know, sort of convoluted or used together. In essence, AI, or artificial intelligence, is a technique which enables machines to mimic human behavior. And that can be done through a variety of means. Machine learning is a subset of AI where you're using statistical methods to enable machines to make recommendations or make decisions based on the modeling that they're able to achieve. And then you've got a subset below that of deep learning, where we're applying more sophisticated multi-layered neural nets, et cetera, to look at unstructured types of data sets. The commonality between all of these things is a couple-fold. One is they use historically observed data as an input. So, right, you need some historical data in order to apply some sort of math and statistics to it to create a model or a framework that mimics the observed stuff in the real world. And then we can create an output based on those patterns so that you can, in a lot of cases, predict those in advance with a relatively high degree of confidence. I think one of the things that we've experienced in taking this to market over the last 5 years is no AI or ML model is perfect. There's no magic wand. It doesn't just turn on and automatically work. It takes a little bit of effort, but the experimentation is sort of the enjoyable part of it, because you start to learn new things. So let me talk a little bit about AI in the workplace. You know, I imagine a lot of these questions are the types that you've seen within your own organization, right? So if you've ever, been asked a question like this or asked a question around something like this is an awesome opportunity to start to build AI in the organization. It brings new insights. It may even provide insights that you didn't expect. So one of the things that I would stress here is that today there's probably no better time historically to sort of bring AI into your organization. And the reason for that is we've had some massive, in the last 10 years or so, some massive achievements in the compute resources, the availability of computers, to be able to do this stuff very effectively and efficiently. The costs have come way down. And the mathematics that go into these have been largely well stress tested for years now. And to give you a sense of that, if we were to go back, I guess a couple of years or so, 10 years ago or so, sorry, my slides are stuck here. There we go. You'd be looking at building these things from scratch. So building machine learning models, in this case, looking at building three relatively simple models, the logistic regression classifier models. That's identifying something that is either a yes or no or true false or something like that as an outcome. A data scientist would have taken several days to do this. And obviously this code looks really beautiful, but in the end, it requires the ability to code. And since then, we've seen the advent of various packages within either R or Python or other programming languages that make this much easier. Scikit-learn is one in particular that is often used in terms of machine learning. Again, a data scientist is often the person that's putting these models or these solutions into place. Takes them a day maybe with these packages. And again, there's code. Code requires obviously building the code, debugging, etc. So whereas that used to take days, again, with the advent of advanced computing and again, the fully vetting these different types of packages, we do see what I would call automated machine learning type of solutions, right? Or AutoML as it's being referred to today. These are GUI-based workflows that do not require necessarily the same level of rigor around the ability to code. So here, as I'm showing, one of our data science engineers from an emerging category, what we would call citizen data scientists, is building a half dozen models in literally the time it takes me to talk through the slide. In this case, he's using Kraken, which is our AutoML product. He's ingesting the data. He's performing critical pre-processing steps, trains these models, performs 5-fold cross-validation, deploys the model, both as an API endpoint and even Kraken hosts it for him. He also is able to download it as a nightly CSV. As you'll see here in a second, he even has the time to perform a little bit of what-if analysis on the predictions themselves. So that enables him to be a bit more prescriptive as opposed to just providing predictions to the key business stakeholders. So again, no coding means no painful debugging when your code breaks. The simplified workflow means there's other talent probably in your organization that can begin incorporating machine learning into their daily tasks on a self-service basis. And for data scientists, we've seen increases in scale as they begin to focus on some of the harder problems within an organization and leave what I would call low-hanging fruit machine learning type modeling to analysts or data engineers. With that evolution in place, where are we at today? So let me talk just a second about some of the things that are going on in the marketplace for AI. Gartner, as you guys probably know, is a third-party research firm. They recently released a study. I think some of these things are pretty relevant. Since COVID, about half organizations have left their AI investments unchanged, whereas about 30% of organizations actually plan to increase those investments. So this tells me that even despite COVID and you heard stories about companies having to furlough, et cetera, these investments remain a top priority. I thought what was really interesting is that about a third of the CEOs at these organizations own the AI initiatives inside their organization. So there's executive sponsorship and champions at the very highest levels of these organizations to make sure that these things remain a priority. In addition to Gartner, what I would bring to the table in our own observations, again, being part of the marketplace here, we've actually seen increased breadth of resources that are being involved in machine learning initiatives, meaning, we may have a customer that initially had one or two individuals that are responsible for their machine learning tasks and initiatives. And now that's expanded to 3, 4, 5, even in some cases, a dozen people that are getting involved in that organization. So again, that is a great sign, I think, for everybody. The other thing that we've seen is a shift in focus to initiatives that reduce costs or create operational efficiency. And just given the times and giving the focus on cutting costs, et cetera, this is natural. So as an example here, we have a customer in the financial services space. They do lending, and prior to using AI, they would have very manual process to basically vet inbound leads and whether or not they wanted to go through the application process with that candidate. In those cases, using a credit check, which costs them $35 each time to do that. They instead trained a model that allows them to pick the best leads, and then in turn actually automatically either decline or approve a loan before having to, or instead of having to run credit for that customer, for that prospect. So that's actually saving them $100,000 a month. This is a relatively small financial company, so that has a meaningful impact. And again, it's one of these cases where they're reducing costs through automation via machine learning. So with the table set, let me turn the stage back over to Mark and talk about Skullcandy's experience bringing AI into the workplace. So Mark.
Thank you, Nick. Appreciate it. And let me get my screen shared here. All right. Can you see that okay, Nick? All right. Good afternoon, everybody. Thank you guys for taking the time to come to this presentation, and super happy to be here as well. This is my first time being at Prepare.ai, and super excited to be here with Nick and with Big Squid to share some of the stuff that Skullcandy is doing in the area of advanced analytics. Just real quick, a little something about myself. I am CIO at Skullcandy. I have responsibility for all of our IT and infrastructure, our digital and website operations, our customer service, and I also am responsible for driving the mobile app development at Skullcandy. And I've been at Skullcandy for 10 years. We're based in Park City, Utah, and prior to Skullcandy, I spent the earlier part of my career in Silicon Valley in the semiconductor industry. So it's been quite a change moving from semiconductors to headphones, but definitely wouldn't change anything. It's been great. One of the things that I really like doing is figuring out ways to apply IT principles in ways that help drive the business forward. And I think with advanced analytics, that's been something that's been really fun to watch over the years at Skullcandy, helping us become a data-driven company and helping us use data to drive and make a lot of decisions. The history, I mean, basically in the time that I've been there, we've been doing a lot of that. And then recently it's gotten really exciting with some of the stuff that we've been doing with advanced analytics. The other thing I really like doing is sharing that information with others like you guys that are on the line today. Unfortunately, we can't be with each other in person, because one of the things that I also really like doing is kind of hearing what everybody else is doing and kind of like having some cross-pollination going on. So I encourage everybody to use the chat or the Q&A, and we can hopefully have some good, somewhat interactive discussion kind of after all this is over. Hopefully it prompts you guys to have some questions. And of course, I've listed my email there to feel free to reach out to me if there's things that you guys want to talk about afterwards. So real quick about Skullcandy. We make headphones and earbuds. We were founded in 2003. We're a global company now, sold in over 80 countries out of Park City, Utah. We are the #5 audio brand in the US after the big guys like Apple, Beats, Bose, and Sony. And we like to think that we're really punching above our weight. We do not have deep pockets like these other guys that are our competitors. We're a relatively small company. We're a couple hundred employees distributed across the globe. But we're doing well. Our mission is to unleash the visceral power of music for all, and our vision is to be the #1 brand for the youthful and adventurous audio consumer. And you guys saw the title of my presentation was the Advanced Analytics Mixtape, and I thought that was a good title for a couple of reasons. I think everybody's familiar with the concept of a mixtape. I mean, basically, it's spawns from the days of the cassettes where you would curate different songs and put them on a cassette, and typically have a theme like Spring Break 1990 or whatever you want to call it. And it's really, the greatest hits are the things that kind of like fall in with that theme. What I want to share with you today is some of our greatest hits, some of the really cool things that we've done with advanced analytics. And really the theme is around driving the business forward and improving our products and improving our customer experience. So if I think about kind of how we got started with advanced analytics, it really started with some big questions from our product team around what if. Things like, what if we could predict return rates on new products before they're introduced? Or what if we could use insights around our customer reviews and warranty claims to understand themes, positive drivers, negative drivers, and sentiment to inform our new product design decisions? And then what if we could use that data to focus our resources better, to improve the customer experience and to deliver better products? So those are the kinds of things that we're driving our initial foray into advanced analytics. That's kind of what got us started. Now, to answer that question 3 years ago, it would have been a process that's probably familiar to a lot of us. Starts usually with Excel, and you dump a bunch of data into Excel. You spend a lot of time analyzing it, tagging the data, trying to figure out where the common themes are. Typically, that's a one-off process, and it's not really repeatable. And so we were doing some analysis, but it was definitely not in an optimal way, and it wasn't something that was repeatable or scalable, I guess you could say. So that's kind of what drove us to start looking at advanced analytics. And this picture actually is blown up poster size in our office. It's on our wall where we have our values listed. And one of our values is we see ourselves as relentless underdogs, and we dare you to underestimate us. But I also think this picture is really a good way to think about diving into advanced analytics. This kid is sitting here at the skate park in front of this, the big bowl here. There's a bunch of people kind of standing on the other side, watching him, seeing what's going to happen. He's getting ready to drop in for the first time, and it's probably not going to be pretty. Best case, maybe he goes in there and flails his arms around and screams and kind of like scoots out the other side and survives. Or maybe worst case is, it gets to the bottom and compresses under all that pressure of the acceleration and wipes out and has to try again. But the point is that you're never going to get good at skating in the bowl unless you start somewhere. So it is all about progression. It's a common theme in a lot of sports, and I think it's a really common theme in the area of advanced analytics. You have to dip your toe in, start somewhere, and just kind of start learning from there. And that's the approach that we took at Skullcandy. And so I'm going to talk a little bit about how that progression evolved. As I mentioned, we've been evolving as a data-driven company for some time now. It started out with basic things like getting a SQL Server data warehouse put in place. And with that data warehouse then, and kind of a single centralized place where we could store information, we really began transforming ourselves into a data-driven culture. We adopted a analytics and dashboarding tool called Sisense, which has really been a key enabler for us. It gives us a way to expose a lot of our data and make it visible and understandable and queryable and explorable to the rest of the company. And so that kind of was our next evolution. Once we were using Sisense, we started using basic things like word clouds and other tools like that to kind of help people get their arms around some of the text-based data that we were looking at, and really trying to understand a little bit better what was going on with things like customer reviews and warranty claims. But we knew that wasn't enough, that there was probably something more that we needed to do there. And so we started exploring some tools like IBM Watson, a partnership with EMC, and using tools like SPSS and R. And none of that stuff really took off with us due mainly to cost and complexity. But along the way, we'd also been sharing our desires to get more involved and become better experts in advanced analytics. And we came across a couple of different opportunities that we took advantage of. And one of them was we ran into Big Squid. Big Squid is it's a Utah-based company. They're based in Salt Lake. We're up in Park City, and they have, as Nick described, they have a tool that really makes predictive analytics very easy for the end user to implement and use. And I'm going to talk a little bit about how we did that with the Big Squid team. At the same time, Sisense was interested in helping us leverage our text analytics more, and they had suggested that we could do a partnership with them and leverage some of the features and functions of Amazon Comprehend. And so really, we kind of got started in advanced analytics by sharing our desires with our colleagues, and in some senses, they kind of raised their hand and said, hey, yeah, we can help you with this. We understand what you're trying to do. Let's partner up and see what we can make happen. So we started down that path. What we put in place had a variety of different tools and techniques. A lot of these things are very familiar, but when you put them together, it's enabled us to deliver some amazing results in advanced analytics. So obviously we're using SQL Server. That's where we're doing a lot of our data wrangling, the cleansing, staging information, and aggregating information. It's kind of our source of truth for the data. We're using Big Squid, the Kraken tool, to implement our machine learning algorithms and our predictive engine. And then that's leveraging several different models to come up with the results that we're looking for when we're trying to predict our warranty claims on new products. We're using Python to do some natural language processing on the reviews and warranty data. And then we're using Amazon Comprehend to do text analysis and sentiment analysis. And then it all kind of ends up in Sisense, where we can visualize the data, do further analysis, drill in, slice and dice it, and develop our insights and our decisions. And this approach worked for us for a couple reasons. It's a fairly simple approach. This was, we actually worked on this pre-COVID, so the local bullet there's a caveat. We liked having somebody local, having the Big Squid guys local, so that we could go to their office, they could come to our office, and we could work together on this kind of interactively in person. And the Big Squid guys and the Sisense guys obviously have a deep pool of talent that they were able to provide to kind of augment our efforts. The solution that we came up with was very easy for the business users to understand and to use. And we were building on these partnerships that we had with Big Squid and Sisense to do this. We did this in a low risk way. We're taking small steps, again, around the theme of progression. And also it was relatively low cost. So we didn't have to invest a whole ton of money up front to start getting results and start understanding some of these techniques that we can use for advanced analytics. Because of the way that we implemented the model in pieces around, having the data warehouse kind of as the central point and then plugging these other things in around it, it's a very flexible model that integrates well with our current tech stack. And with Sisense already being well adopted in the company, there was a clear pathway for integration there and a clear pathway for people to kind of understand how they were going to see the data kind of at the end of the process. So when we started looking for the source data, we were basically pulling things like reviews, and as most of you know and are probably familiar with, a brand like us, consumer electronics product, we live and die by our reviews. Reviews are critical. What we see on Amazon, what we see on our own website, our retailer sites, and that sort of things. It's very important to understand what's going on there with reviews. So we created a homegrown scraper to pull reviews off of Amazon and our other sites where reviews are stored. And then we eventually migrated that to a tool called Blueboard, which makes it a lot easier. Blueboard is a tool that connects directly to some of these review sites and pulls and aggregates those reviews, and then you can access them via an API in Blueboard. So that was covered on Amazon and our other major retailer sites, our own .coms. Our warranty claims data, on our warranty claims, that's a homegrown system that we have. And so we had access to all that data. When somebody submits a warranty claim, we provide a free-form text field for them to tell us why they're submitting a warranty claim, what's wrong with their product. And that's a wealth of information there. that data that we're pulling into this effort. And then when we're looking at trying to forecast what our costs will be for warranty in the future, we need to bring in things like our forecast, our shipment history, product master data, and other product attributes. And that's all coming from our ERP system and our data warehouse, SAP Business ByDesign. So once all that stuff is aggregated together, no discussion around a systems implementation is complete without a diagram like this that kind of shows how everything hangs together. I'll go through it quickly, but you can see SQL Server in the middle. This is where we're storing and staging all the data. So we're feeding our warranty information and our reviews information in to the SQL Server database. We're also feeding in forecast, product attributes, product returns, actual shipments, and those sorts of things into the database. To do the analysis on predicting future warranty costs, we're using the Kraken predictive engine to do that. So that information then feeds into Kraken. We run the model in Kraken, and if we like that model, we can save it out as a model that we can then compare side by side with other models that we've created in Sisense. If we don't like that model, we can iterate. So there's an iterative process here. On the text information like reviews and warranty claims, those are feeding into our NLP engine. And we have a Python NLP engine that runs that looks for common themes among warranty claims and reviews, and that outputs that information into the database. And then we also have Amazon Comprehend looking at that information and then determining sentiment on those reviews and warranty claims, and that's feeding directly into Sisense. So Sisense is kind of the end result where everything ends up based on the data processing that's happening in Kraken through the Python NLP engine and through Amazon Comprehend. And that's where we can really derive the insights around what's happening with our claims, what's happening with our reviews, what's our projected warranty claims look like in the future. So what kind of project team did it take to do this? We formed a team with our product development department. There was a few guys from product development that kind of came up with these ideas. They served as subject matter experts and they helped validate the data. On the IT side, we helped establish the architecture and gathered together all the data and did the integrations, connected all the systems together, made the connections to our Amazon Web Services and Amazon Comprehend. The Big Squid team were our data science experts, and we leveraged the Kraken Big Squid or Kraken machine learning engine. And then Sisense helped us with our architecture, our Amazon Comprehend integration, and also gave us some data science expertise there. And then really what this gave us, setting it up like this, was it allowed our in-house resources to really learn from people that were very familiar with this, because we don't really have anybody in-house that's an expert in data science or advanced analytics or predictive analytics. So this gave a really good opportunity for our team to become familiar with those techniques. So to prepare the data, I just wanted to talk a little bit about what the data set has to look like. So for predicting returns units in the future, basically we have to provide records to the model to train on. And those records contain things that we think would factor into what would be driving returns. And so things like, what's the shipment history on the product? What's the forecast for the product in the future? What's our history of returns? What are the different attributes of the product? For example, is the product a Bluetooth product? Is it a wired product? Is it an earbud? Is it a headphone? Those kinds of things all drive returns rates. What are the themes of the warranty? Are there common themes like people returning because of batteries, or people returning because of connectivity, or what are the reasons why we're getting the returns? Prices, how mature they are in the product life cycle, how we feel about the history of the product in terms of the accuracy or the volume of the history, and then whether or not that product is actually active in the returns life cycle. We've been selling products for many years, and so there's certain products that are end of life and aren't being returned anymore. So that's an example of kind of what the data set looked like for training the predictive engine on helping us predict returns. For analyzing the text from the warranty claims and from our reviews, we had a more simple set of data. we basically classified the data type as a review or a warranty claim, and then where that data came from. Was it from Amazon? Was it from our own website? Was it from our return system? And then in the case of a review, what was the star rating? What was the title of the review, and what's the text in the review? So it's a very simple data set, but kind of free-form data. The text could be paragraphs long in some cases. And so when we, real quick, just what it looks like when you run the predictive engine through Kraken. It's very simple and very intuitive. You basically connect to your data source. In our case, we'd be connecting to SQL Server. You select the data set that you want to predict on, and that would be whatever data set we had defined in our data warehouse. And then you select the thing that you want to predict. And so in our case, we want to predict what our returns costs are in the future. And then you run the model, and it comes up with a analysis on how accurate the model is. Big Squid has a choice of several different models that it runs. And then you can look at the output and the fit of the model based on what your data set is. You can also evaluate the model by looking at things like what are the key drivers in the model, and then what is the how well does the model fit. And then you can do what if scenarios once you're in there, like what if my costs increase, what if my forecast decreased, and you can kind of play around with different things to see what the impact is on the model if you change various things in the model. And then at the end of that, and at the end of that, you can take the model and export it back for visibility inside of Sisense or inside of our data warehouse. So what are some of these results that we looked at? I love this picture because these guys look like they are really loving what they're listening to right now. And I think we kind of felt that way once we started looking at some of the results that we were getting from putting these models together and running these advanced analytics. And so I was going to share just a couple of examples of things that we were able to do once we kind of got this data running. So on the predictive side, forecasting returns on NPI, this is just what the output from Sisense looked like. The red bar is the forecasted returns, and the purple bar is the actual returns. And so you can see the fit actually was really well, where forecast was fitting very well towards the actual. And then we were able to get that where you see the orange bar, that's our predicted returns going forward. This happens to be for a product line that's forecast was going down, so you don't see a whole lot of returns happening in the future. But we basically got immediate value out of running that predictive engine when we got this, because this is one product, but we were combining all those products together, looking at what the cost implications were, and the PD team, product development team, actually use this data to kind of identify areas where it looked like returns were going to be a little bit high for certain products, and is there anything they can do to reduce it, or understanding more in the model why it was what it was. So that's an example of how we got some value very quickly from that. On the text analytics, this is a great example of something that it was just buried in there and we didn't really see it. We started seeing people using the words, "I bought these for my son," quite a bit on certain products. And so what we were able to do inside of Sisense is filter out things that were referencing where the customer was talking about, buying for their son or getting them for their son or things like that. And you could see then which products were kind of popular when customers were talking about buying them for their son. And it was very interesting to see here, in this case, it was our two products, our Hesh family, Hesh and Bluetooth Hesh, which when we look at it now, it totally makes sense. It's a really good price point product that a lot of parents buy for their kids, super durable, and it's an over-ear headphone that kind of makes sense as something that you buy for your son. So that was just really an interesting insight that we got. There's all kinds of nuggets like that we were able to distill out of the text analytics once we got it. And then on the sentiment, this is a really interesting one. So we started looking at the 5-star reviews, and we started looking for where there was a positive sentiment, we started looking at the 1-star reviews, and we started looking at where the sentiment on the 1-star review was positive. And we saw these kinds of things where someone rated us 5 stars, but they would say something like, "The sound is good, but it hurts my ears too much to enjoy them." So in a way, that's kind of like a conflicting topic in a review, where you give a high review, but then you say something negative inside the review. And these are obviously things that we need to watch out for when we're paying attention to what people like and don't like about our products. So it was a very easy way for us to quickly identify situations where we had reviews that were kind of in conflict with the sentiment around what they were talking about. So along the way, we learned a lot of lessons, and I think a couple of these I wanted to share with this group. The first one is be open to making false starts on data modeling. So especially when we were trying to train the predictive engine, we really had to think hard about the data that we wanted to put in there and what types of data would be useful for driving the predictive engine. And so it was really good to have a flexible model that allowed you to easily add and remove fields and columns from that. Second is you may not like what you see, especially when you're looking at product reviews. You see all kinds of negative things that people say about your products, and it hurts your pride a little bit. But at the same time, it's important information to know, and it's important to take action on it. If there's things that you can do about it to improve your products, to improve the customer experience, we want to be all ears, but definitely hard to see some of those things. I already talked about making the data easy to add to and modify. You definitely want to be able to iterate when you're doing this and quickly churn through things. One thing, we got almost instant value once we saw the data. So, we dumped this data into, through the Kraken engine, through Amazon Comprehend, into Sisense. And once we saw it in Sisense, the engineers were going crazy just looking at it and really like trying to distill out all these new facts and really digging in and getting a lot of value out of it. So it was very worthwhile. The other thing that this did is it gave the company, Skullcandy, a better understanding for the concepts that are needed to do advanced analytics. And so people started identifying other areas where we could use advanced analytics to answer business questions. And the final point here is really just around that taking a leap or dropping in or progression, right? Once you take a leap into that unknown, you can get unexpected insights, things that you never even knew were in your data because you're seeing it in a completely different way. So for us, just talk quickly about what's next. We are looking at, actually, we're currently using artificial intelligence as a lot of companies that are in the direct-to-consumer space have experienced like huge increases in demand due to COVID. A lot of people are working at home. A lot of people are ordering stuff online and that sort of thing. And our customer service volume has gone crazy over the last 6 months. And so we're looking at using AI to answer questions that customers are asking of our customer service team, things like order status and things like that. On the text analytics side, we've used text analytics to analyze the feedback from our employee surveys. We're looking at our competitor reviews and seeing kind of what people like and don't like about our competitors. And we're also looking at our net promoter scores using text analytics. On the predictive analytics side of things, we're looking at predicting size of market segment size, looking at it for our demand planning as well. So there's an opportunity there. We're looking at merging data together. So the obvious questions around reviews are, if you've got a positive or negative sentiment in reviews, what are the common themes around those and how you take those and kind of distill them into actionable insights that the product team or the customer service team can go after. And then operationalizing all of this. Some of these things, especially the interaction with Amazon Comprehend, is kind of a manual process right now of feeding the data in and then pulling it out. We want to start leveraging some of the capabilities, the APIs, and those kinds of things. I think that's my last slide. Final thoughts. Final thoughts for this group around advanced analytics. Think about how, if you're looking at and thinking about doing an advanced analytics project, think about how it could apply to a common business problem and then use that common business problem to learn the advanced analytics techniques on. It's a lot easier to analyze something that intuitively people kind of know and they already have a feeling around it, and then you're using advanced analytics to look at that, and it allows you to kind of like test your model, pressure test your model. Setting up an architecture to encourage repetition and iteration and fine tuning, I think, is important. You don't want something to be so monolithic that you can't change it along the way. Start small, demonstrate the concepts. People start to get it when they see it in a smaller scale, and they can come up with more ideas about how to use it. And then my final point is just to remember it's a progression. I mean, it's something that we're going to want to, Skullcandy is progressing on this all the time. We're growing and we're learning more all the time about this, and it's definitely something that I think is worth diving into. And with that, I'm going to wrap up here. Thank you guys very much for your time. I hope you found something useful out of what Skullcandy's done, and I would really look forward to some questions. I think we've got maybe 6 minutes for questions.
Yeah, thanks, Mark. I'll field some of the questions. Actually, I got a couple of my own that I kind of want to drop with you too. So first one for you, Mark, specifically. A common theme that I hear from machine learning engineers is that it can be really difficult for a company to move from the machine learning model to action. So how would you suggest an analytics team communicates these types of advanced analytics insights to business stakeholders?
Well, for us, what really worked was getting the data into Sisense, which is a familiar tool among our business users already. And it allows people to kind of, in a way, explore their own pathways. And so, like, if I'm an engineer and I'm looking at the data output in Sisense, I'm thinking about it one way. If I'm a customer service manager, I might be thinking about it another way. If I'm the CEO, I might be thinking about it another way. And so putting the data in a format that it's got that advanced analytics foundation, but then it's very explorable and user-friendly in that fashion, I think was the big win for us and the big learning for us.
Okay, great. I have one for you, Nick. In your experience, what does the ideal team look like to ensure long-term success with machine learning initiatives? Ultimately, who should be involved?
Yeah, it's a good question, and I think it depends a bit on the company size and what the resource commitment is there. Large organizations are able to hire out data science teams and then scale it by using them as what I call a centralized clearinghouse for data science projects. It may not always be the data science team doing it, but it may be line of business analysts and engineers that are working on problems more directly. For most companies, it's a combination of an individual that has the understanding of the business problem. Typically, it's an analyst, business or data analyst, and then a data engineer, somebody from IT that has the access and knows the ins and outs of the data needed to support a problem. And then the last piece is actually probably most important, which are the sort of business stakeholders, the people that have input and should have the ability then to use the output of those models on a day-to-day basis. I think one of the things that's largely missed is that those folks don't always get to be part of these projects. And it's really critical because they're the ones that are going to use it, adopt it.
Excellent. Okay, and Mark, I have one more for you. This one's maybe a question, maybe a little bit of an innovation idea, but I'll ask it for the audience here. Regarding machine learning for the listener, can AI be used at the consumer level based on daily usage of a product? So kind of getting into, can we optimize things like balance or EQ or volume levels based on kind of the environment where audio might be consumed?
I love that question. I love it. And actually, that's interesting. I didn't really think about this. But in some ways, we are already using AI to improve the listening experience on two of our products right now, on our Crusher ANC and our Crusher Evo product. With the Skullcandy app, you can take a hearing test that basically then adjusts the sound profile to compensate for deficiency in your hearing. So like if, for example, as you get older, your sensitivity to the highs decreases a little bit. Or if you've got, less hearing in your right ear than in your left ear or whatever. And it's a very simple hearing test, kind of similar to what you might take at the doctor's office, but there's a lot of processing that goes on underneath that to implement a digital signal processing algorithm in the headphone to adjust the sound compensation. And I would encourage anybody that, that's interested in trying out a Skullcandy product and seeing some really innovative technology, check out those products and look at the difference or listen to the difference that you can hear with that algorithm running to help improve the sound in your headphone.
Awesome. All right, I'm going to take time for one more question here. This one goes to you, Nick. Question is, getting started with ML can be intimidating. So how does Big Squid work with companies to get started?
Yeah, good question. So it'll vary a bit depending on, again, the goal and objective that the company comes in with. If it's purely experimental, it might be first identifying a specific application for machine learning that drive some business value where there's good data, where there's a bit of a shared ownership across all the stakeholders. If there's a known issue in a known application, then that might be a little bit different. It might be diving more into the ins and outs of exploring that data and how we might structure data to be most effective at answering that business problem. And again, I think one of the things that we've learned over the last 5 years is that part of the process is probably the most important, is thinking through the problem in the right way. So that when you start putting it into a machine learning pipeline like Kraken, or frankly any other, that you're sort of putting the right inputs in so you can get the right outputs to be using thereafter.
Excellent. I think with that one, we'll wrap here and let you guys move on for the rest of the show. Stop by the expo hall, enter to win an Echo Dot at the Big Squid booth. That's my one plug I'll give you.
Nice. All right. Well, thanks a lot. This has been a lot of fun. Hopefully you guys enjoyed it, and really enjoyed presenting today. Thank you.
Yep. Thank you, Mark. Thank you, everybody.
Bye.